Solubility looks at how much will dissolve. This is defined as the number of grams of solute that will dissolve in 100 grams of solvent at a specific temperature. That means that when you are provided a solubility, you will be given the number of grams of solute in 100 grams of solvent, and you will be told the temperature. Now let's talk about the 3 levels of saturation. Solutions can be saturated, unsaturated, or supersaturated. Notice that all 3 of these have the statement at a given temperature. A saturated solution has the maximum amount of solute that can dissolve. This amount is the solubility and is also known as the solubility limit. An unsaturated solution is one that has less than the maximum amount of solute that can dissolve at that given temperature. It is below the solubility limit. And finally, the most confusing of the 3, the supersaturated solution. It has more than the maximum amount of solute that can dissolve at a given temperature. It is above the solubility limit. So this is a model that sort of explains how we can have a supersaturated solution. We're going to use weightlifters as our model. So this model is going to look at weightlifting as an example. So the maximum that this weightlifter can lift is 300 pounds. That's his maximum. If I have anything less than 300, but I do hold the weight in my hand, then I have anywhere between 1 and 299 will be unsaturated. Anything above 300 would be supersaturated. But that doesn't explain how he can pick up more than 300 pounds when we just said his maximum was 300. Well, right now, he can only pick up 300 pounds. But in a moment, this butterfly will come flying down and land on the barbell. He now has more than 300 pounds, but he is only able to lift 300 pounds. But he can hold a little bit more. Now, if you put too much on, then it will crash. Notice that this is very unstable. If you tickle him a little bit here, the butterfly will fly away. The butterfly flies away, and he goes back to having just 300 pounds, what we would call saturated. So how can we tell if a solution is unsaturated, saturated, or supersaturated? Well, there's a test for that. These are our 3 test tubes that we're going to test. How might you describe them? They are all clear, light blue, so there's no way to tell by looking at them which one is saturated, unsaturated, or supersaturated. For this test, we're going to add 1 crystal of solute to each test tube to see what happens. After we add the crystal, we will still have a clear light blue liquid. But what happens to the crystal? The unsaturated solution is still able to dissolve more crystal, and so it does. And so what we see is that the crystal disappears. It actually dissolves. For the saturated solution, it is already at its maximum, so the crystal will remain. And finally, what happens to our supersaturated solution? Well, that crystal grows larger and larger, sometimes filling the container with solid. So this test tells us what we had. Was it unsaturated, saturated, or supersaturated originally? Can't tell by looking, but after the test we can tell what it used to be. So that tells us what it was. Now we want to know what it is currently. For the unsaturated solution, there's no way to tell what it is now. We would need to retest until it behaved like a saturated solution. And the sign for saturated solution is that there will be a crystal left in the container. We can see that in the saturated solution, the crystal remains undissolved. This is now a saturated solution with 1 crystal still in it. And finally, we look at the supersaturated solution. After the crystals are added, the solution is now just saturated. It is not supersaturated. And how can we tell? Well, notice that there are crystals in the container. Just like the saturated solution, having crystals in the solution is one good sign that you have a saturated solution. So after adding the crystal, the unsaturated one is now, we don't know. The saturated one is still saturated, and we can tell. And the supersaturated one has become saturated. And again, we can tell because we see the crystals. Solutions can be described as concentrated with a relatively large amount of solute, or dilute, which have a relatively small amount of solute in the solution. Here we see two test tubes. One has a dilute solution and the other has a concentrated solution. It can easily be seen that test tube A has a relatively smaller amount of solute than test tube B in the same amount of solution. This tells us that test tube A would be considered dilute, whereas test tube B would be considered concentrated. What happens when we have even more solute in the solution? Now, when we compare test tubes B and C, we find that test tube B is dilute, while test tube C is concentrated. This is why it is of particular note that these two terms are both of relative concentration. That means that test tube B can be both concentrated and dilute, depending upon what it's being compared to. That is because relative is a comparative number, not a specific number.